Hi class, welcome to our Trivium Homeschool chemistry class. Today we are going to start learning how to balance an equation, and it's really kind of not too difficult and just takes a little bit of practice. But before we do, I would like to once again review a little bit of what we learned in our last lesson. This won't take very long, but I think there's some important information that you'll need to know that'll help get there. Also, you may look at our textbook, Exploring Creation with Chemistry by Dr. Weil. It's the Apologia. And if you have questions, we'll be working out of pages 120 to 124. Also, when we finish the assignment, you are to do on your own problems 4.6 and 4.7. Okay, here we go. So let's review our previous lesson. A change in a chemical is called a chemical reaction. We could write it like this: carbon plus oxygen yields carbon dioxide. But scientists and chemists usually don't do that. They use abbreviations because they're less bulky. And when we put it into an abbreviated form, remember we call it a chemical equation. Here it is up in an abbreviated form. We have C plus oxygen equals carbon dioxide. Let's remember, on the left-hand side of the yield sign or the arrow, we have what are called the reactants. That is because the atoms and the molecules that appear on this side react together. On the right side, we have the product, remember, and those are the atoms and the substances that acted together, and it was the right amount of whatever that created this reaction, and this is what it was, the product. Okay. Let's start with also when we talked about burning up coal. We had one carbon dioxide atom, just like here, and we had two oxygen atoms, well, a molecule. And once it broke apart, the two oxygen atoms broke apart. They went to recombine, and there they formed carbon dioxide. Okay. So with that in mind, let's look at our example of combustion of methane and what happens in our combustion of methane. First, we start with our reactants. We start with a methane and two oxygen molecules. The oxygen molecules each split apart into two oxygen atoms, making a total of 4 oxygens, 4 hydrogens, and 1 carbon. They all recombine, and this is what it looks like. We get 1 CO2 and 2 water molecules. So when we look at this, this starts our process. This is the reaction side, and this will be the product side, our end product after it recombines. We're going to continue using our example right here because I think it's important that you see when we're in algebra and that you remember from algebra that when we have two like signs, we just simply add them and we get 2x. X plus x is 2x. Just like in our final equation, we had 2 oxygens. So what we did was we had, this was our equation, and what we did was we took 1 oxygen plus the next oxygen molecule, and we got our 2 oxygen molecules. Same with the hydrogen. One water molecule and another water molecule is 2 water molecules. We have eliminated all of the bulkiness of our equation up here to 2 oxygens and 2 water molecules. Okay, so we're going to be moving on to our next lesson, and this would be our lesson for the day. And let's, after reviewing this, we kind of have an idea of how we're going to go about this, but there are a couple of tricks that we're going to talk about as we go through this. Now, in order to, we'll continue using our combustion methane, and in order to make a clear idea of what we need to do is we always need to keep track of the atoms. The number of the atoms on the reactant side need to be the same as the numbers on the product side, and this will always balance our equation. For example, if our reactant side had 5 hydrogen atoms, then our product side also has to have 5 hydrogen atoms. Otherwise, it's not balanced. And according to our law of mass, it would be violated. Okay, so here we go. To count the number of atoms, we'll first start out with the carbon atom up here. Since this is our first molecule, we'll write the molecule down. We are going to look to the left of the carbon, and we do not see anything, so we are just going to assume that this is 1 carbon. We write 1. Then we look to the right of the atom, and we see that there is not a subscript number there, so that also we're going to assume is a 1. 1 times 1 equals 1. Let's go over to our product side. Here we have our carbon dioxide, and we're going to look to the right. There isn't a number, so we assume that that is 1, and we multiply it again. There is no subscript by 1, which equals 1. So far, this carbon and this carbon are balanced. Let's go to the hydrogen. We have 1 hydrogen. We look to the left, all the way up front here, there isn't any number there, so it remains 1. We look to the subscript, and we do have a 4, which is why we write the 4 here. We multiply it. 1 times 4 is 4. Let's move on to the product side. Here's our hydrogen atom. We have to the left, we have 2 hydrogens. And then we are going to look at the subscript, and we also have 2. 2 times 2 is 4. The hydrogen on this reactant side and the hydrogen on the product side are both balanced. That's good. Let's look on to the oxygen over on our reactant side. We have 2 oxygens times 2 in the subscript equals 4. Okay, now I need to have a little bit of your attention because this part takes a little bit of getting used to, and it's a little bit different than some of the problems, but I'm going to tackle this heavy one first so that you can get a hang of it. To figure out the total number of oxygens, we must determine how many oxygens come from the product side. There is no number to the left of our CO2, right? So that is 1. But there is a number to the right in our subscript, and that is 2. Right here. So 1 times 2 is 2. Next, there's we look over here to our oxygen. Remember, we are not looking to this number on our left. This is a molecule. We will look to the beginning of the molecule, and it is 2. And we look to the left to see if there's a subscript here, and there is no subscript behind the oxygen. 2 times 1 is 2. 1 times 2 is 2. What do? We add these 2 numbers, and we get 4. So our oxygen molecule is 4, and again, we have this is 4. This is a balanced equation. I'm going to give you an idea of what an unbalanced equation looks like. First, we have this very big, long, complex chemical. We're going to look at the reactant side, which is here, and then the product side. We're going to start out with our hydrogens. Remember, we look to the left. This is 2, and we write the 2, and we look to the subscript times 1. There is not a subscript there, equals 2. Let's go to the product. We have hydrogen here. Look to the left. There's 2. We look to the right. There is nothing, so that equals 1. So that is also our reactant side, and our product side in the hydrogen is agreed, balanced. We'll go to the Okay, now we're going to look to the left, and remember we go to the front of the molecule. We have a 2, and there is not a subscript, so it's 2 times 1 equals 2. We'll come over here. Here's our Cl, and we look to the 2. We do have a 2 there, and then we're going to look to see if there's a subscript. Oh, there is. 2 times 2 equals 4. Okay, right here, we could just stop our equation right here because right here it says that it isn't balanced. But we can continue and go on and see that the rest of this as well is not balanced. We're going to continue on now, and this will be my last example before I let you get started on your own. We look at our carbons. We're going to look to the left. We have a 6. No subscript. times 1 equals 6. Let's move to the product. We have 1 carbon, there isn't anything in front of it, times 6 equals 6. The carbons are balanced. Let's look at our oxygens because we have more than a couple of different molecules with oxygens in them. So watch how we do this part. We have the oxygen. We go to the 6. There's our 6. We have a subscript of 2. 6 times 2 is 12. We are going to add whatever we have over on this side of your equation because here's our adding sign. 6 times 1, there is not a subscript, is 6. 6 plus 12 is 18. And again, we do the same over here. We have our oxygen molecule. We go all the way to the beginning. There is not a number here, so we're just assuming that this is a 1. When we look to the subscript, it's a 6. Now we are going to add again. We have a 6 to the right and a 2 in the subscript. That's 12. 6 plus 12 is 18. Those are balanced. Not so tricky, is it? The last part, we have a hydrogen. We look to the right. What is it? 6. We have a subscript, 2. 6 times 2 is 12. And one more time, here's our hydrogen on the product side. We look to the right, to the left, there isn't anything, so we just assume that is a 1. We multiply it because there is a subscript of 12 by 12 and it equals 12. This is a balanced equation. Okay, I'm going to let you get loose on your own. Thank you for paying attention in our class today. And again, if you have any questions, please look in your textbook. Thank you.